After a few tests of crimp terminal wire pullout, I knew I needed a better setup. And after seeing this on video, of me almost destroying my scale, I decided I wouldn't do any more wire pull tests until I have a somewhat proper setup. And that proper setup would be a test stand, a force gauge, and some assorted clamps. Not a lot of stuff needed to do this somewhat right. I will buy the force gauge. I can get what looks like a decent one for under $100. For the clamps, I will probably try to make something to grip the wire. That may end up being the trickiest part. For the stand, I'm going to build that. I didn't see anything I liked that was less than about $400, and now that is a bit over the budget. I'm going to use this piece of aluminum for the base. It's a piece of scrap aluminum I bought a long time ago. I got it cheap. Well, I got a few of them cheap. So now is the time to put one to use. It's about 14.5 inches in diameter and 3/8 inches thick. It will handle anything I throw at it. Being scrap, it came with 3 holes drilled in it. I have made some spacers to hold it in alignment while I mark it for hole drilling. I'm using screws and washers to hold it to the CNC spoil board. The 3 screw holes are my reference points. It's not that critical. I just want the clearance holes for the mounting of the column to be opposite one of the 3 holes already in the aluminum. I can't directly drill the holes I need with the router, but I can center drill a small spot with the CNC router, and then I can finish drilling the proper size hole on the drill press. It's a shallow drill spot I can create with the router, so here I have a center drill in the drill press where I'm drilling a much deeper location hole for a regular drill bit. I found this step does increase the hole location accuracy, adds a bit of time, but I want the holes to be as accurate as possible. I let the center drill move the piece into position with a bit of light pressure, and then drill a deeper hole. 2 of the holes, the 2 used to mount the column, have to be drilled to clear an 8mm bolt, and I think my bit is getting a bit dull. It's a pretty good size hole in this plate aluminum, but it should be cutting a bit better than that. Now the rest of the holes are drilled with a number 7 bit. These holes are on 2-inch centers, and I will thread them with a 1/4-20 thread. I hope this will give me a bit of flexibility in mounting whatever kind of holding fixture I end up needing. I want this to be a flexible piece of equipment. The stand itself could be used for a lot of things. This bit is getting close to the end of its life as well, but it has drilled a lot of holes. I don't really like using the black oxide finish on aluminum. The bright finish drill bits do a better job. I didn't go quite deep enough with the centering bit, so I'm going to put a chamfer on the holes with the hand drill. It does make for a cleaner threaded hole. It's worth the extra effort. Now I did start off tapping the holes with a tap wrench, using the 1-2-3 block to help me keep the tap straight, but that was taking forever and my fingers were starting to get tired. I'm still using the 1-2-3 block to align the tap, but now I'm using the hand drill to actually tap the hole. I have the clutch on the drill about 4 or 5 stops down from the drill setting. When it slips, I just back out the tap a bit and go again. I don't really think I could break this tap with the drill set on the drill setting. Well, maybe if I really tried. I don't want to take the chance. Decent quality taps are getting a bit expensive. Using the drill is so much faster and so much easier on the fingers. Maybe not great on the drill chuck jaws, but the clutch kicks in before the tap slips, so I don't see any harm. I should have used this method from the start. This is what I'm going to use for the column. It should handle a few hundred pounds of pressure with ease. The 2 round holes on the center line of the extrusion are for tapping an 8mm by 1.25 thread, hence the 2 clearance holes for the 8mm bolts. I want the tap to enter the hole straight. If I'm a little off on this large of a tap, it will become very hard to turn. The tap just will fit in the holes of this 1-2-3 block, so that should give me a nice straight starting point. I do want to be careful when removing the block. I don't want to ding the upper threads on the tap. Now I'm pretty sure I wouldn't be able to break this tap using just this tap wrench, and if I have it going in straight, I shouldn't need to increase my leverage any. Okay, that went quite well. Starting a tap straight is so very important to getting a good thread. I'll clean out all the chips and see how it fits. It looks like I have my holes aligned where they should be. That is always nice. I have about 2 times the screw diameter for the thread depth. That should be plenty. I I didn't look it up or anything, but that should give me at least a couple thousand pounds of pull-out resistance. Way more than I will need. That looks to be a pretty good start. I am going to need some feet, as right now it is setting on the 8mm screw heads. I think I'll make some plastic feet that will press into the 3 holes I used for alignment. If it's not stable enough, I'll make some screw-on feet later. But I think the 3 will be okay, and that will be the easiest to implement. I had to decide how I wanted to arrange the needed pieces. I've decided I'm going to put the force gauge on the column, and maybe just use a small vise as a clamp on the base. So with this arrangement, I want to be able to move the force gauge a minimum of 2 inches up and down, either with a lever or knob. At this point, I haven't decided which I would prefer. But the entire mechanism has to be able to move up and down on the column easily. So I've got to make a carriage that can move on the column and clamp firmly to it. And since I have some scrap 3/8" acrylic sheet, I'm going to use that for the carriage and probably the movement mechanism. It's just easy to work with. I have 2 layers of masking tape on all sides of the aluminum extrusion, and I'm adding a piece of 20-pound bond paper to each side for spacing. I'm using Weldon No. 16 glue here. It's thick and I have a bit of work time with it. It makes for stronger joints than the Weldon No. 4, but it takes longer clamp and setup time, which in this case is good. I will put enough on the joint so that when it's assembled, some of the glue will squeeze out. That way I will end up with almost no void spots. I'll use the 1-2-3 blocks to aid in alignment. Even this long after joining the pieces, I can still move them. I couldn't do that with the Weldon No. 4. Once I'm satisfied I have the alignment correct, I'll put a bit of pressure on the pieces. Then I'll put a little weight on it and let it set. I'll let it set till the squeezed out glue becomes like a hard rubber. I'll be very gentle removing it, as the glue is still quite soft. I'll also be gentle getting it ready to put the other side on. I don't want to put any prying force on the sides. It's plenty strong to handle at this point, but a large force could break the joint. I guess the tape is a bit thicker than I thought. I do want there to be plastic-to-plastic contact for gluing. Okay, removing 1 layer of tape did the trick. I'll glue this side just like the first side. Once again, I'll put some weight on it and let it set. Again, I'm being very gentle removing it from the aluminum. The glue is still soft. And since the glue is still soft, I can scrape off the excess with a razor knife. I'll put a bit of weight back on it, and this I will let set overnight. I have sanded the joint smooth because I'm going to double up the acrylic, overlapping the glue joints. To clamp this in place on the aluminum column is going to take quite a bit of force, so I thought I would overdo it with the acrylic. This is going to take a dab of glue here. One thing I do like with the Weldon 16 is the working time. There, I didn't have enough, and I was able to pull it back apart. I wouldn't have been able to do that with the No. 4 glue. I'll get it aligned and lightly clamped. How long it has to set is quite dependent on temperature. I kept checking on it till the squeezed out glue became like rubber, a soft rubber in this case. With the glue still being soft, I can just scrape the excess off, and that is much easier than sanding the dried glue. For the last piece, I did need to sand the joint a little bit. I want a smooth surface for a good strong bond. Another nice thing about the No. 16 glue is that it will do a small amount of void filling. At least it seems to. So I think that is good enough, as smoothness goes. I'll fix up some blocks and clamps to help me align the last piece. Once this is glued up and clamped, I will let it set overnight, and it should be like one big chunk of acrylic. To lock the carriage in place, I've got to make a special headed bolt that will slide into the back slot of the aluminum extrusion. The thing is, it can only be 7.5 millimeters deep, so I don't have a lot of space. I've cut a piece of 60-61 aluminum bar down to fit, and drilled and countersunk for a socket head cap screw. Of course, I had to trim down the socket head some. There is not a lot of aluminum left under the head of the screw. I think it was just under 0.1 inches. I did end up with the countersink hole a tiny bit larger than I would have liked. I'll press the cap screw into place. It didn't press in but 0.05 inches, but it only has to resist turning, and that's enough press fit to accomplish that. So I think it will be okay. I am going to have to grind off the edges of the cap screw to match the bevel of the aluminum. This should get the job done. That much aluminum to aluminum contact should hold pretty tight, if I can put enough pressure on it. Now for that pressure, I need a good sized knob. So I've got a slice of 1.5 inch diameter aluminum bar. I have drilled and tapped for a 6mm thread, the thread I need for my special headed bolt. I'm going to put some knurling on the knob so I can have a bit of traction in tightening it down. I found out I would rather have less depth of knurl than too much. Too much just makes for a very rough feeling knob. I think that looks pretty good. Feels pretty good. Not too sharp, but still with plenty of traction. I'll clean it off and see how it does. I'm going to use a fiber washer to keep the aluminum knob from digging into the acrylic. That seems to be working pretty good. I think that will hold for what I need. The force gauge I ordered does a maximum of 65 pounds, so I would like it to hold to at least that much. 65 pounds will let me test some pretty good sized crimp terminals, maybe up to the 16 gauge wire size, at least some 16 gauge crimps. I believe that will easily hold 60 to 70 pounds. For my up-down motion section, I've decided to use this. It's way overkill, but it's not that expensive and it's quite easy to mount, and I really like using them. The rail is supposed to be 200mm in length, so I'm going to cut it in half. That will give me close to 100mm of rail, minus whatever I lose from the cut. As it turns out, the rail is a bit over 200mm, so if I can keep the Dremel sort of straight, maybe I won't lose but a few millimeters, and one of the pieces should be right at 100mm. The slide is right at 45mm in length. It can overhang the end of the rail by a few millimeters, so I should be able to get a bit over 2 inches of movement, which is what I'm aiming for. The surface of this rail is quite hard. Really, it seems the entire rail is quite hard. Can't cut these with just a regular bandsaw or hacksaw blade. I did try one time with a bimetal hacksaw blade. The blade lost, but it did scratch the rail. In fact, I can't even take the sharp edges off with a file. I'm using the cutoff wheel to smooth the cut edges. Could do it with the grinder, but I did get a pretty clean cut, and I'll be finished with this before I could even get the grinder set up. I have one piece that's a little over 101mm and one that's over 97mm. I'll use the 101mm for this. Now, a very important part after cutting these is to remove all the grinding dust that's collected on them. It is abrasive and will destroy the ball bearings if not removed. I will do multiple cleanings. I'll use alcohol, then a light machine oil. I'll keep doing the cleaning until I don't see anything come off with the oil wipe. This is how the rail and slide will be positioned. I'm not mounting it in the center. I'm going to move it closer to the side. That way if later I want to mount a ruler, I will have enough room. I do want it to move up and down in a straight line, so I'm going to go the extra length to mount the rail parallel to the side of the carriage. I'll clamp it in place and then use a drill to mark the mounting holes. Then I'll finish drilling the holes for a 3mm screw thread. I do want these holes to be very straight, so no hand drilling here. I will also use the drill press to tap the holes. These will be very long threaded holes compared to the diameter of the screw. I want to have a very good thread in the acrylic, so it's worth the extra time to set up and make sure the tap is completely perpendicular to the surface. Also, the 3mm tap is a very small tap, and if I'm not careful, I could even break it in this plastic. For lubrication, I'm using an ice cube. It will keep the tap cold, and water seems to be a good cutting fluid for acrylic. You would be surprised how hot the tap will get cutting its way through the acrylic. The ice really does help keep it cool, and seems to make a much cleaner thread than without it. Of course, after cutting with the water, I always wipe some oil over the tap. It is quite a deep threaded hole for a 3mm screw, but I want to be able to tighten these down as there are only 4 to hold the rail in place. I'll use the 123 block and a parallel to align the rail to the carriage. The thread is so fine on these 3mm screws, it takes forever to install long ones. Once I have all 4 close to making contact with the rail, I'll apply pressure to the rail, forcing it up against the parallel. Then snug all 4 screws, then go back and tighten all of them. It may not look like much force, but I expect I'm over 5 inch-pounds of torque. I'll do a rail cleaning with a soft clean cloth, and then install the slide. With no pressure on the slide, not the smoothest of motion, these were cheap. But with just a tiny bit of down pressure on it, it's quite smooth. A mesmerizing sort of feeling. I've got to have some stops to keep the slide from sliding off. and I think this is the best place to put them. Again, I'll be using this Weld-On number 16 glue. It lists a working time of 5 to 6 minutes. I would say that is a bit optimistic. Seems more around 3 minutes, and that's with it a bit on the cool side. I'll clamp it up and let it set. Now I won't be picking the thing up and the slide falling off. Last thing I want is the slide hitting the ground and ball bearings going everywhere. Stops are on, and I've drilled and tapped 4 holes for mounting the gearing mechanism. This is the part that will mount to the slide and have the rack attached to it. I've already glued mounting tabs to it, 3 3mm clearance holes on the bottom tab, and 3 3mm screw thread holes on the top tab. The 4 mounting holes for the slide are oversized a bit more than I intended. I grabbed the wrong drill bit, but it will do. The rack is 100mm long. It's a Module 1 20-degree pressure angle spur gear rack, and I've drilled and tapped it for 2 3mm screws. I will tighten down these 2 screws pretty tight. All the pressure I will be applying will have to be carried by just these 2 screws, so I guess this will be the weakest link. I'm going to use some small washers on the slide mounting screws. These are 3mm screws as well. I'm lining it up by sight for now. After I get the gearing mechanism on, I can make any adjustments I need. So far, so good. I love the way the linear ball bearing slides move. Just something special about them. These are the plates that will make up my gear assembly. This doesn't get glued together. I'm going to be using screws. There are no threaded holes in either of these pieces, only clearance holes and a bearing mounting recess. Before I laid out these pieces, I had to make my decision whether to use a lever or a knob. I ended up going with the knob. I think it will give me a bit more pressure control. Both gears are Module 1 to match the rack, a 21 tooth and a 58 tooth, so a bit under a 3-to-1 gear ratio. I'm not sure I can comfortably get to 50 pounds with this ratio, but I'm going to give it a shot. The shaft with the bearing is for the knob and the small gear. It is held in place by the recess cut out of the plastic plates. The short shaft is for the large gear. It is held in place with a screw. I didn't do a very good job cutting the keyway into the shaft, but it will do. The screw and washer hold the gear on, and the keyway keeps it from slipping on the shaft. I'm not putting any thread lock on the screws at this time. I will in the future if things work like I'm hoping they will. I'll put a little oil on the short shaft. For the large gear, the shaft is stationary, so the gear will turn on the brass shaft. That bit of oil will keep everything in good shape. Now to put it together. I've made 4 spacers to mount the gear assembly with. I will tighten these screws pretty good. Well-cut threads in the acrylic really do have good holding power. They're not great for a lot of remove and install cycles, though. The knob came from Amazon. It's about 3 inches in diameter. That is why I'm not sure I can easily get 50 pounds of force from it. Also, I don't have flat spots on the shaft for the knob. I will probably add those if I don't have to remake the gear assembly. Here is the force gauge mounting plate. I've glued tabs to the top and bottom to match the tabs on the slide mounting plate. 3 3mm tapped holes and 3 3mm clearance holes. This is the force gauge. It's from Amazon and I paid $70 for it. Maximum load on it is supposed to be 65 pounds, and it mounts with 4 4mm screws. The difference in diameter between the 3mm and 4mm screws is only 1 mm, but when using them, the 3mm screws seem so tiny compared to the 4mm screws. The tabs overlap one another to mount the gauge, with the bottom tabs having the threaded holes on the gauge mounting plate, and the top tabs with the threaded holes on the slide mounting plate. This should allow me to change gauges or test equipment pretty easy. I think that about does it with the carriage assembly. I'll put the clamping knob back on and see where I'm at. The 2 main pieces. The stand feels very sturdy. I don't think I'm going to have any worries about it not handling the pressure. Carriage slides right on. I do have to line up the head of the lock bolt. But once on the column and with the knob tight, I don't think it's going to move. I'll find out here in just a bit if I'm right. Thank you for watching.